The reaction between hydrogen chloride and oxygen reaches equilibrium in a closed container, according to the following balanced equation. And you're given it, and you're given a minus value over there, which means it is an exothermic reaction. Then it says the graph above is not drawn to scale, and it shows how the amounts of reactant present in the container change with time at specific temperatures. The volume in the container is 5 decimeters cubed. How does the rate of the forward reaction at time t1 compare to that at time t2? Write down greater than, smaller than, or equal to. Well, it is greater than, and the reason that you need to give is, what is rate? Rate is change in something, concentration or amount or color divided by change in time. And therefore it is in essence change in y over change in x, which means it is a gradient. So when you're talking about this, you can say quite clearly that the gradient at t1 of both graphs is greater than the gradient at t2. So you needed to kind of come up with that word gradient, or talk about the change in the number of moles. How does the rate of the forward reaction and reverse reaction compare at T3? At T3, the number of moles is remaining stable, and therefore you land up with an equal rate, because the rate of the forward reaction is equal to the rate of the reverse reaction. Then it says to us, calculate the number of moles of HCl at equilibrium. So the first thing I'm going to do is I'm going to consider how many moles that I have to start with. Well, I had 1,0 and I had 0,3. That was my start. At equilibrium, I can see quite clearly that I have got 0,1 of the oxygen, which means I must have used 0,2 of oxygen. Now let's look at our mole ratio. I've got a 1 and a 4. So 1 is to 4. If I use 0,2 of oxygen, that means I must have used 0,8 of HCl. If I started with 1, used 0,8, where did I land up? I landed up at equilibrium with 0,2 moles still in the container. So my answer is 0,2 moles. The temperature is now increased. How will this change affect the position of the equilibrium? Now, watch carefully how I'm going to write this, because you want to try and do it as briefly but as detailed as possible. So, delta H is negative. Therefore, exo. Increase in temperature favors endo. Therefore, reverse favored. And then finally, how will, actually answer the question, how will this change affect the position of the equilibrium? Yeah, I think saying reverse favored is probably sufficient, because that's the position of the equilibrium. Then the next one, how will each of the following changes affect the equilibrium concentration of chlorine? Chlorine is one of my products. Write down increases, decreases, or remains the same. So, if I look at this balanced equation over here, I am going to first add water vapor. All of these were gases. So, if I add more of the product, which is water vapor, the reaction is going to favor the reverse reaction, because it will try and use up that water. What will therefore happen to the chlorine is I will get less of that. What happens to the equilibrium concentration of the chlorine? It is going to decrease. Then a catalyst is added. Catalyst has no effect on equilibrium. Just happens faster. And the volume of the container is increased, so that means that the pressure has been lowered. So let me count my gas moles. 5 gas, not just any old moles, gas moles. and 3 gas moles. Low pressure favors the side with the most gas moles, and therefore it will favor the reverse reaction, which means it will decrease the concentration of chlorine. We've got this long story about sportsmen's and putting on ammonium nitrate, and is it exo or endothermic? Carrying on. On researching the dissolution of calcium chloride, you find the following energy profile. That is an exothermic energy profile. Label the names of the quantities represented A to E on that energy profile. So I'm going to say A is, if I look on the axis, what is it? It is the energy of the reactants. B is the energy from the reactants to the activated complex, so that is going to be my activation energy. C is from the activated complex all the way down, so it is total energy released. This over here is my energy between the reactants and the products, and that we call delta H, or the heat of the reaction. It does say the names, so you should have said heat of reaction. I was generous there. And finally, the last one is the energy from 0 up to the product, so that is the energy of products. What is the name associated with position X over there? This is your activated complex, also known as a transition state. That would be acceptable. According to this energy profile, is the dissolution of calcium chloride endothermic or exothermic? Explain your answer. And it is exothermic, because net energy release, or delta H turns out to be negative, or something along those lines. Then finally, on further research, you found that the dissolution of ammonium nitrate in water is given by the following reaction. And they give you a reaction, and in it, they put this information here. I have to add energy. If I'm adding energy, it means it is an endothermic reaction. What does the abbreviation AQ represent? It actually means aqueous. But what does that mean? It means dissolved in water. That's what aqueous actually means. In the reaction, there appears to be an energy value given to me over here. What is the position and the magnitude of this value indicate about the reaction? Well, the fact that I am adding it on the reactant side tells me that it is an endothermic reaction. Energy was added. A fertilizer company produces ammonia on a large scale at a certain temperature. The balanced equation is given below. To meet an increased demand for fertilizer, the management instructs their engineers to make necessary adjustments to the dynamic chemical equilibrium of the reaction to the yield of ammonia. In a trial run on a small scale in the laboratory, the engineer makes adjustments to the equilibrium mixture, and the graph is below. Between which time intervals is the system not in equilibrium? Equilibrium is when the concentrations are constant. So when is it not in equilibrium? Between T1 and T2, between T3 and T4, between T5 and T6. Using the principle, identify and explain. Briefly explain the changes to the equilibrium mixture made at each of the following times between T1 and T2. Let's see what happens. There is something extreme. There's a big jump in N2. Everything else, not such a big jump. So in other words, N2 was added. That's the stress. Therefore, the forward reaction is favored. And you can also say there, and that is in order to relieve stress by using N2. So those are your 3 points. That was the stress. That's what happened. And this is explaining it in terms of Le Chatelier's principle. You don't have to restate the principle. It doesn't say state the principle. All right. Next thing is what happens between T5 and T6. Over here, everything seems to change quite gradually. So we need to think about it. If it was a change in pressure, all of the concentrations would immediately increase. That is not true. What we're seeing is that the N2 increases and the hydrogen increases, which means the reverse is favored. So that's what I'm just going to write down to start with. I'm going to get a mark by saying reverse favored. It's not a change in pressure. It's not a sudden change in any of the concentration of reactants and products. So that pretty much leaves me temperature. So now I'm going to consider that this is a exothermic reaction because delta H is negative. So if reverse is favored, you must say that forward is exo. Therefore, reverse endo. Endo favored by temp increase. So let's look at our marks. We favored the reverse reaction. The forward is exo and the reverse is therefore endo, and the endo is favored by a temperature increase. Underline that because that was the question. What happened? What was the change that happened? Okay, and if you want to, you can just put in a bullet over there, but it was only out of 3 marks, where you say endo is favored by a temper increase, since the system will try to cool itself, something along those lines. At T3, the pressure is increased, and both the reactants and products showed a sudden increase in concentration. So that's a change in pressure. Use Le Chatelier's principle to explain how the equilibrium now establishes itself between T3 and T4. So the first thing you're going to say is you're going to say, I am going from 4 gas moles, not any old moles, to 2 gas moles. Pressure increase. Tries to shift to side with least gas moles. Now I've explained in terms of Le Chatelier's principle. Gas moles. Therefore, forward favored. Therefore, more NH3 concentration. Something along those lines. You can get your 3 marks out of that. You want to talk about these gas moles, not just moles, hey? And then you're talking about Le Chatelier, and then you're saying what actually happened. Then it says to you, if you were the engineer, what temperature would you choose and why? By using either high, low, or medium, and then a brief reason. Now, obviously, the first thing is that to favor the forward, you've just said the reverse is favored by a temperature increase. So if you want to favor the forward, you're going to have a temperature decrease. So I'm going to write temp decrease favors forward. Temp increase increases rate, which in an industrial process is important. How fast did this happen? And then finally you're going to say, therefore, medium. State Le Chatelier's principle. This is straight out of your book, and you need to do it as book work. So, If a system at equilibrium experiences a stress, for example, change in temperature, pressure, or concentration, the equilibrium position will adjust to accommodate the stress. Methanol is an important alcohol with many uses. It can be manufactured from carbon monoxide and hydrogen according to this equation, and once again we've landed up with an exothermic reaction. State and explain the conditions of temperature and pressure, high or low, that will maximize the yield of this reaction in terms of the principles. So, again, in terms of the principle doesn't mean stating the principle. So you're going to start with reaction is exo. Therefore, favored by low temperatures. The system tries to make itself hot. Then the next one, 3 gas moles to 1 gas mole, less gas moles favored by high pressure. As system tries to minimize pressure, and it does that by minimizing the moles. That's it.